All right, good morning, everyone. Welcome to this week's episode of Pulumi TV. My name is Luke Hoban, and today I'm going to be talking about migrating to Pulumi. So if you've joined us for any of our previous live streams, a lot of the demos we've shown have kind of been about applying Pulumi to new kinds of applications, taking a standalone new application, you want to build a greenfield application, and using Pulumi with that. But when we talk to users and customers and about how they're adopting Pulumi, a lot of the questions and the discussion is about the process of migrating from some existing system to Pulumi. And so today I wanted to spend a little bit of time talking about that process, kind of a few things. One, where people are thinking about migrating from to Pulumi, how Pulumi is fitting in with their existing systems. And then when they do think about migrating to Pulumi, where is it that, what are the tools to do that migration and to help sort of match the concepts from within the previous system over to what they're going to do with Pulumi. So along the way, I'll show a handful of kind of examples of using Pulumi in some of the domains that folks have been migrating from. And of course, in future video streams, we'll kind of dive into some of these specific areas in more depth and talk about that migration process as well. But for today, let me start kind of high level and talk about some of the ways that we've seen folks migrating to Pulumi. So broadly speaking, I sort of see two kind of categories of when I go and talk to somebody about Pulumi. The existing tools they're using, which they're looking for Pulumi to replace or to augment. One category is they've got a set of kind of infrastructure markup tools. And so this could be either they're using the native systems in the individual cloud providers, so CloudFormation or as a resource manager, or even here we might consider Kubernetes YAML or something, the underlying core kind of API representation for the cloud platform. Or they're using some existing tool that layers on top of that, like Terraform. In each of these cases, they're kind of using some way, they're already kind of bought into infrastructure as code. They understand that that's valuable, but they want to move from infrastructure as code to really infrastructure as software and to take, instead of just the low-level building blocks, to be able to treat their complex infrastructure as something that they can manage with pure, true software. And this is what's sort of motivating them to look at Pulumi. The other side of that is kind of folks coming from more domain-specific tools. So folks who really want more productivity than they can get from working with the raw building blocks in CloudFormation or Terraform or what have you. And so they're looking for one of these tools that really makes a particular vertical really nice. So serverless framework if they're doing serverless applications, or a Docker Compose or Kubernetes or Helm if they're doing container-based applications, or a variety of other sort of integrated vertical solutions that really say if you're working within a very kind of specific sandbox, you can get a really great and productive experience, but you may not be able to easily move outside of that sandbox. And so this is sort of, on the left, we've got sort of the lower level, details of the underlying platforms. And on the right, we've got the higher level productive model of development. And really, in both of these cases, the folks moving to Pulumi are kind of tend to be looking for both the infrastructure as software, being able to use software and all the benefits that provides to manage this kind of infrastructure, but also the ability to not have these two sides be siloed, to be able to get the productivity of the high-level domain-specific tools, but combine that with the low-level control that they need from the underlying platforms when they need it. And so this is sort of what Pulumi does, and Pulumi can sort of creates a kind of a continuum between these two ends of the spectrum, and really can, we've seen examples of Pulumi being used as a replacement or augmentation of sort of all of these tools, plus some others, because it can sort of scale up and down but across this spectrum. So I want to talk about some of those in more detail, but first I should mention one important category of migration that I sort of skipped over in that first slide, but that actually is sort of almost the biggest category of things we see when we go out and talk to customers, and that is folks who haven't even gotten to the stage kind of really thinking about infrastructure as code yet, or not thinking about it really seriously. And those are folks who maybe are either pointing and clicking in the console to create some resources, and that's kind of how they're bootstrapping their their cloud application, or they're using bash scripts or some sort of imperative Python application to go and hit the APIs and create the resources they want. And so this, most of the benefits we're talking about here are things which are generally true for any infrastructure as code offering. And so Pulumi really, one of the key differences Pulumi has from just using a Python script to call the AWS APIs is that you get this true infrastructure as code. You get to describe the desired state of your infrastructure. You get to run an update, and that will make the minimal set of changes to achieve that desired state. And just as importantly, then you have repeatable deployments. So when you have a Pulumi program, you can go and take that and stand up a new copy of it, completely isolated from the previous copy. You can do that just on every PR to your application, or you can have a dev and staging build, or you can have a dev environment. And so this ability to sort of describe your infrastructure with code is really a significant benefit that many folks have. The key thing that Pulumi sort of brings to this is that as well as being able to get the benefits of infrastructure as code, you don't have to leave all the creature comforts of a real programming language. So for folks who are familiar with JavaScript or Python or Go or any of the other languages that Pulumi supports, you can get all of these benefits of infrastructure as code and about desired state of your applications and being able to deterministically drive towards that desired state. But you can still get all of the software engineering benefits of being inside kind of a real programming language. And so that's really the main thing that when folks are talking about moving from something they're managing using sort of scripts or a console into Pulumi, it's often the case of they're coming from an application development background. They feel more comfortable using code than using sort of a new YAML dialect they've got to learn, and so Pulumi looks attractive from that perspective. Now, for when you're coming along this sort of dimension, there's a few things that are sort of interesting to keep in mind as you think about how you can kind of map this into Pulumi. So the first is you don't have to do this sort of transition all in one. It's very easy to just take one little piece of an application or just some net new pieces of an existing application and incrementally adopt Pulumi into those. And so if you've got existing infrastructure, you can just continue to use that and manage it in the existing way and access it and build on top of it from within a Pulumi program. And so there's a couple of tools available for this. Generally, these .get APIs, which allow you to access an existing resource and use that as an input to new resources. There's also a set of tools for kind of adopting these then into your application and having them be managed by Pulumi now instead of being managed by the console. And I'll show those in just a second. The second one is, really because, Pulumi is letting you use a programming language, you can continue to do all the free-form sort of stuff you might have done using scripting or bash scripts or whatever. And you can go and shell out to a tool you have locally that you need to go and create something. You can use built-in libraries in Python or JavaScript to parse some file format that you need as input. All these sort of free-form things you sort of are worried you might be constrained if you go to some kind of YAML-based system. You have those all accessible to you within Pulumi. And so that's an important thing to keep in mind as you're thinking about this. Many of the constraints that may have kept you away from adopting infrastructure as code in the past are not as significant, and because you can sort of do this free-form application of logic into your infrastructure as code definitions. And then the last thing is application code, and this is something we just like to, as we introduce programming languages as a tool for doing the infrastructure provisioning. We do like to remind people that this does not constrain the kinds of applications that they can deploy. So you can write your infrastructure in Pulumi using JavaScript or Python or Go, but you can still deploy application code written in any language. If you have .NET and Java inside your company, you can deploy applications in those and just write your deployment scripts in JavaScript. And so using Pulumi does not constrain in any way what kinds of infrastructure and application code you're able to deploy into your application ultimately. So with that, let me just talk a little. Let me show a quick demo of what that looks like to do some of this kind of incremental adoption. And I'll show a few of the tools that are available to do that. So here I've got just a very simple Pulumi program which creates an EC2 instance. And it creates this AMI, and I just grabbed this as the AMI for Amazon Linux inside US West 2, where I'm going to deploy this application. But you'll notice I left the subnet ID blank. And so to get a subnet ID, I might want to sort of attach this instance to some existing subnet that I have inside my cloud platform. I may not want to create a whole new VPC and subnet just for this instance. And so this would be, I've got some existing infrastructure, maybe managed with CloudFormation, maybe managed with, that I set up through some scripting. And so I'll show a few of the ways that I can go and integrate this into that existing infrastructure. So the first and sort of the most obvious is I can come over here and I can actually just find one of my subnet IDs that I want to attach to in the console. So let's say I had point and clicked around, created a VPC. Maybe I'm just using the default VPC that AWS gave me for free. I can just go ahead and grab this subnet ID here, paste this in, and now I can go ahead and deploy this. And just for those of you who haven't seen kind of Pulumi being used to deploy something, let me just come back over here and I'll just say Pulumi update and show you what it looks like. So this is a stack that I have, and a stack in Pulumi is an instance of this application. And you'll see this instance just wants to deploy a single EC2 instance. And in this case, I'm deploying that into US West 2. So I can say yes to the preview because I do want to go ahead and create that instance, and I'll just watch this create. And when it does create, we should see that I have a new instance inside AWS running inside that subnet. And I'll come back and show that in just a second. That probably will take about 30 seconds. But I might not want to hard code this string in here. I might want to actually make this a parameter so that, if I'm in my staging environment, maybe I attach it to a different subnet. And so for that, Pulumi has support for config. And so I can say let config equals new pulumi.config. And I'll call this, since this is in the migrating project, I'll just do that. And then I can say config.require, and I'll say subnet ID, maybe. And so I can say let subnet ID. So now I can do this sort of thing, and just pass that as a configuration. And what this means is I'll get it from the externally provided configuration. And so every time I stand up a new instance of this program, I can parameterize it with a new subnet. And so over here I can do, and actually we'll see that I already, I'll just do it here, migrating subnet ID. So I'm going to do Pulumi config set, and then I'm going to set this to that same subnet ID here. And then I'll go ahead and replace that. And I'll come over here and say Pulumi update. And actually, because I didn't change anything, this should say that I don't need to make any changes to my application. And so it says no change, and you can see the details, and it'll say that this is the same. And so I'm going to go ahead and not proceed with that because there's no changes to make. And so you can see that I was able to move from hard coding that in to passing it in through configuration just without actually having to change any of my existing infrastructure here. And so that's an easy way to sort of parameterize on that subnet ID. Now if I stood up an instance of this stack that uses a different subnet ID, or if I change the configuration setting, maybe I change it to point to this subnet ID. Copy that. And now I run Pulumi update again. Now we'll see we actually have to tear down the old instance and create a new instance. We have to replace it so that we can stand up the instance in the new subnet. So all that's kind of what you might expect. There's a couple other tools you have available to sort of adopt in and use existing infrastructure. So one of those is, if I want to actually get this subnet and get other properties of the subnet, I may not want to pass individual parameters or configuration into my program. I may just want to be able to parameterize by a subnet ID and then just go and find all the other details related to that and use those as inputs. And so I can do that by saying something like let subnet equals aws.ec2.subnet.get. And this will be, I'll call this subnet. And now here I can pass that subnet ID. And what this will do is look up that existing subnet in AWS in this case by its subnet ID. But now I have a full instance of this subnet where I can get all of the different properties available on that thing. So I can get, what availability zone it's in. I can get the tags on it. I can get the VPC ID that it's part of. And so I can use this, so instead of me having to pass in all of these pieces of information separately, I can pass in just the one I care about and then find all the other information and use that to parameterize things. So I can use this VPC ID, for example, as input to some other resource in my application. So that .get is a very handy tool for being able to take existing resources in your target cloud provider and bring them into a Pulumi program without having to change things. This .get will actually also store that into the state of the application. And so you can, for instance, use this to import a resource, and then you'll have it waiting in your program. And then you can change that over to be actually managed by Pulumi in a future update. Well, there's also a set of useful tools if that by itself is not sufficient. If you want to do some sort of richer searches, you can do something like maybe ec2.get instance. Like, let's say I want to find an instance and I want to find it by some parameters. So maybe I pass in some filters or some tags that I expect to be on it. And so I can use these to go and search AWS in some richer ways for existing resources, and then pull those into the program and use those from within Pulumi. So the core to all of that is just, it's very easy to go and take existing resources and start using them from within a Pulumi program in a kind of robust way. And so I'll just skip back and kind of talk about how we use that in some broader examples. So that first example was really kind of about just sort of infrastructure as code benefits and adopting existing resources. But a lot of the folks who are coming to Pulumi do actually have existing experience using a tool like CloudFormation or ARM or Terraform to do infrastructure as code for the cloud. And so for these folks, the thing we hear kind of from them generally is a few different things that are really attracting them kind of to Pulumi and that are causing them to think about Pulumi. The first is the benefits of real software engineering, effectively treating infrastructure as software, not just as code or not just as text. And this is a variety of things. This is the ability to get rich tooling that you expect from the kind of software and application code that you write, whether it's in Java or C# or Go or JavaScript or whatever it is you're doing in your application code. You get a bunch of really rich tooling, and bringing some of that kind of tooling experience into your infrastructure is really important to scaling infrastructure up in a reliable way. One of the key pieces to that is getting sort of type checking, so getting feedback as you're working, getting completion lists, getting error reporting, making sure that you get that feedback early and often around the correctness of your infrastructure software. And then finally, sort of functions and abstraction and the general ability to take pieces of your code, give it name, create reusable components, and then ultimately to put those into package managers and share them and use them between members of your team and across folks inside the Pulumi user community. And so this packages notion is really what enables folks to use higher level components instead of just copy pasting around blocks of YAML or blocks of declarative markup. They can really reuse packages. And importantly, because they can attach to existing package management ecosystems, they can actually use versioned packages. And so packages which are versioning as part of the package manager and can be pulled in at specific versions, and using Semver made sure that they remain correctly up to date with the latest fixes from downstream, and then can adopt breaking changes when they need to. And so really the sort of robust package management kind of discipline that folks expect from their software, we can apply that also with Pulumi to infrastructure. And then finally, a key benefit that folks see relative to sort of CloudFormation and Azure Resource Manager is having a unified model across clouds and also sort of across technologies. So whether you're doing containers or serverless or raw infrastructure, using a single model to kind of talk about all of those things. And so there's a few things that sort of are worth calling out for folks who are using some of these systems. One, especially for folks who are using Terraform, often have questions about kind of the state files. And so Pulumi, by default stores all the state files in a backend service, and so you kind of don't have to deal with a lot of the management of state files in the same way as you might with Terraform. And so this current state of your application is stored in the Pulumi service. And you can always run deployments from your local machine, and those deployments are executed entirely on your local machine. But the state is backed up into the Pulumi service so that multiple people from your team can work collaboratively on a project, or you can move between machines easily and have your state robustly managed, and so that you won't, there's no possibility of accidentally losing or corrupting those state files. The second thing, which is sort of notable for all three of these, is the Pulumi providers, the way that Pulumi talks to the target cloud platforms, actually generally sit on top of the Terraform provider ecosystem. So the Terraform provider ecosystem is a great set of open source projects for reusing the various cloud platforms through a schematization of those platforms. And so one of the things this means is that in general, folks kind of coming from Terraform or who have existing Terraform assets can port or can sort of evaluate their code on a kind of one-to-one basis. So you can take an existing Terraform resource and very easily say, here's the one-to-one translation of that into Pulumi. And folks using CloudFormation and ARM, there's generally, because these are a representation of each individual resource in the cloud provider, there's normally a very close mapping between those two. So it tends to be very easy if you've got existing resources in any of these systems to map those into Pulumi. The key thing, though, is then once you've done that, then you have the opportunity to really take advantage of all the things that Pulumi provides. So that's when you can then start refactoring your code to take advantage of functions and control flow and parameterization and all these nice things that you get. And you can add sort of richer typing and structure over top of the code to ensure that you are able to catch bugs earlier as you iterate on this code in the future. And so all the benefits we talked about you can apply kind of after having ported some code. The last piece to kind of think about in all of these sort of DSLs, whether it's CloudFormation YAML or Terraform HCL, is kind of interpolation. So all of these systems have some way of kind of embedding some extra logic inside the way that you map between outputs of one property and inputs of another property. And those tend to be these very specialized and somewhat ad hoc kind of languages that are embedded inside these YAML files. And so one of the key things in Pulumi to think about is whenever you have one of these interpolations, you actually kind of get the full capabilities of the host language, so JavaScript or Python, to replace those with. And so instead of being constrained to maybe 5 or 10 built-in functions that might be available in for instance, CloudFormation or ARM, you have access to the entirety of JavaScript and of the Node.js runtime, and even of the Node.js package ecosystem. So if you need a library for doing computations of CIDR blocks for your networking stack, you can go into NPM, look for that library, pull it in, and use that. If you need to parse some file format that you have on disk that you want to use as parameterization, you can just pick up a library from NPM that knows how to parse that file format, and use that from within your application. And so this ability to embed, any code you want, any logic you want inside of your deployment programs is actually one of the really significant changes that you get kind of as you think about moving from CloudFormation in ARM and Terraform to Pulumi. And so let me quickly show kind of an example of some of that. And so I have over here a example kind of in Terraform, and this is I'm doing a Terraform example here. This really could be an example in any of these from any of these systems, but I'll start with a Terraform one just to give a sense of kind of what some of this looks like in this kind of one-to-one translation, and then what some of the benefits are that Pulumi can offer. So for folks who haven't seen Terraform before, this is Terraform HCL, and sort of kind of its own domain-specific language that's a very kind of declarative model for describing infrastructure. And so let me kind of just hand translate this to begin with in kind of that one-to-one form, and then I'll show some of the improvements that we can make. So first off, this creates this IAM for Lambda, and so let me create that role. First thing we see is this is a resource AWS IAM role. So we can access that by saying aws.im.role. And so you see it's sort of a very one-to-one, the same shape of resources that are available here are going to be available inside Pulumi. The difference being that I actually have kind of rich IntelliSense and completion lists, and I can go and explore what kind of things are there in this IAM namespace. There's roles, there's role policy attachments, and get the documentation for those things right in line. And if I mistype, that, I can get this, error message. I can get this error message saying, did you mean role? So, easy feedback, quick feedback on some of those things. So I'm going to call this IM4 lambda to match that previous example. And then similarly, I can kind of get completion list showing me all the different properties that I must or may specify. And so you can see there's only one that I must specify, which is this assume role policy. And so I'll go ahead and do this. And I can do sort of the same thing as what was done in that example. One key thing to note, though, in this example is I kind of had to do this with this, embedding just some raw text. And so this was just a way of embedding, some other completely different file format inside of this program. Because JavaScript, JSON objects are a frequently used thing, it's actually very simple. I can just copy paste this in. And now I'm actually embedding that JSON right inside my JavaScript file. And so very simple to do that. And I have kind of a working Pulumi program. And here I didn't have to sort of break into some totally different file format. It's really just JSON objects, and then I'm turning that into a string to pass in here. So let me then go and take this other resource, and I can say aws.lambda.function. Oops, and I'll call this text lambda. And similarly here, I can do, I have all the same kind of properties available. And so, for example, even that more interesting environment, I can go ahead and do this kind of thing, right? But you notice things like I get error reporting saying, hey, you're missing some properties. So if I hover over this error, you can see the property handler is missing. So a few of the properties I needed to specify over here. And so I won't go ahead and do all of these things, but you can imagine I can kind of fill these out as well. And so I should note actually this example that I'm showing here, if I come back over, this is actually just taken from the AWS Lambda function docs on the Terraform site. So this is just sort of the most basic kind of Lambda example. In practice, these things often get more complex as well. It's just sort of starting with a very simple example here. So I'll just delete this for a second so I can show a couple of other kind of handy things that we get with this assume role policy. So because we know what some of these shapes are actually supposed to be, I can actually also go ahead and say let policy of type aws.im.policy document. And I can come over here and just paste this thing in. And the nice benefit I get again here is now if I make a mistake, like I mistype the name of a statement, or I say, don't use the right kind of effect. There's only a few kinds of effects that are allowed. I actually get errors in my program. And so again, I can find these errors all the way deep down into the specific file formats and JSON payloads that are expected for some of these things, right in line by doing, because I have a type system available in Pulumi. And so I'll keep that like it is. And so this gives me the ability to get type checking on that thing. But because we have arbitrary functions as well, we can also create little handlers that help with this. And so one of the folks who has been an early adopter of Pulumi actually did a recent contribution to this library that adds a little helper function, assume role policy for principal. And this function actually takes, just the principal and then automatically creates all the rest of the boilerplate you need for an assume role policy, because they're always effectively the same. So here I can just say service : lambda.amazon.aws.com. And that was just this part of the document. And so now this is a little handy helper where I can just specify just the piece I care about, and I get then a policy document. And that ability to sort of give these things names, share them, we can publish that in this package itself or in another package, is a really handy thing to create sort of reusable components within our application so that we don't have to repeat this kind of boilerplate over and over and over again inside our software. And so that's a very simple example, but in this example, the sort of the biggest thing you kind of notice is just, hey, this is a lot of stuff I've got to do just to kind of get a function running. And so that's when we kind of have some higher level wrappers that kind of do more of this for you automatically. And so in previous examples, we've talked a lot about some of those, but one of those we have is new aws.serverless.function. And here I'll call it lambda. I can pass some options, so I can specify the role or the policies. So I can say EC2 full access. I don't know if that's really what we want. And then I will pass a event handler. So and so here, I can create a Lambda, but instead of me having to put it inside a zip like this and get the zip, author that in some other payload and embed it inside like this, I can actually just write the code for this in line. So I can say here console.log ctx dot, and then I can say maybe log the function name every time it gets invoked. And so this is our ability. We have this handy ability to kind of write lambdas in line. And so in this case, we built this little wrapper AWS serverless function over top of that to make it really easy to create simple lambdas that want to live just in line inside your program. And so this is the core kind of building higher level components and starting to get more of that kind of serverless and high level experience, but based on top of the raw building blocks of the same things we can do here, aws.lambda.function. Okay, so that's a quick example of kind of what it can look like to move over some kind of Terraform examples. And let me then go ahead and talk kind of from the other end of the spectrum. And so from the other end of the spectrum, we're kind of talking about some of these high-level tools that let you work with either containers or serverless applications, but that really kind of treat those as their own little sandbox. You typically kind of have to use these in combination with other tools to manage your cloud deployments, and they sort of are their own little islands that you kind of work on for the subset of your application that gets to take advantage of either containers or serverless. And so again, there's key benefits that you get, with Pulumi around sort of software engineering. Instead of using YAML files and that sort of thing, you get, the full benefits of sort of tools and type checking, and you get that unified API across clouds and technologies. But the one key thing that I think most folks using these tools find they're looking for when they consider Pulumi is the ability to not kind of have a black box. And so the ability to, when they want to get down into a low-level detail, to just have a really easy escape hatch, to combine some raw AWS infrastructure or raw Azure infrastructure with the ability to write very simple Docker Compose-like container definitions, or very simple high-level serverless applications that stitch together event sources and functions and deploy them all in a really convenient way, but while still having access to provisioning the raw AWS resources with the full capabilities of the underlying platform. And so the two things to sort of keep in mind in this category, one, because it's not a black box, Pulumi will give you visibility and access into all the individual resources. And so it's not trying to, like some of these tools like Docker Compose or Serverless, hide the underlying abstraction. Pulumi really is trying to give you visibility into all of the actual resources that you're managing, even while it's giving you access to some higher level components to use to put those things together. And so that is a difference, and something that some folks find is actually really helpful for them understanding how their applications are going to work. The second one is that whereas with many of these tools, they separate the notions of the application code and the infrastructure code. So the description of how to deploy the infrastructure lives in a separate file from the description of the actual application code itself, and they're typically versioned on a different cadence. And that's certainly possible with Pulumi, but Pulumi, because it sort of unifies these two worlds, also gives you options to actually combine the way that you deploy application code and infrastructure code, even when targeting kind of real production kind of systems. And so that is something we often find, especially with kind of folks who are thinking about how they structure their kind of modern cloud development teams. More and more so, the application authors have dedicated infrastructure as part of that application that versions really one-to-one with the application logic for that particular component. So maybe they have a DynamoDB table that's specific to that application, or they have a Redis cache that gets deployed specific to that application component or that service. And so in all these cases, they want to actually, as well as deploying their code, they want to deploy updates potentially to their infrastructure. And so those things benefit from being versioned together. So let me show you really two quick examples of kind of these style of things where we're moving from some other very high-level description into Pulumi. And I'll show two examples, one kind of looking at Docker Compose and one looking at serverless. Okay, so I'll close this guy down and I'll open up a Docker Compose file. And this Docker Compose file is in the Docker Compose tutorials. This is sort of one of the very first examples they give for using Docker Compose, and it just stands up two services. So it stands up a web service and a Redis service. The web service is built from some local Docker file, and the Redis image is built from a image on Docker Hub for the Redis Alpine image. And so the key thing for Pulumi is that there's libraries that give us sort of a similarly high-level view of how to describe and deploy containers, but that do it on top of existing raw infrastructure. So whereas this compose file really can be used just to deploy locally, with Pulumi we can get that same kind of productive benefit of this kind of level of description, but we can apply it to real infrastructure running on AWS, for example. And so I have here, I'm using the cloud library, this cloud AWS, which is a library that has a bunch of kind of convenient things built on top of the underlying AWS resources. So in this case, I'll say, let web equals new cloud.service. So just like we have services here, we have a component called cloud.service. And I'll call this one web, and I'll provide some parameters. And so the most important parameter this has is a set of containers. And so we can have multiple containers per service, but each one of those containers has the same sorts of options. So I can say build dot, and I can say ports, and this port is going to be port 5000. And so similar kind of look to this, a few more lines of code in this case. We're actually right now working on a change to allow you to, if you only have one container, just write it like this, which is even more similar to that. But even with this, still very simple high-level way of describing, hey, I want this container built from this local Docker file to be deployed into a service that is available on the internet. And then I can write the second one. I can say let Redis equals new cloud.service. And again, containers, Redis. In this case, instead of me building it, I'm going to say Redis Alpine. I'm going to use an image instead of a build so that I get it from Docker Hub. And so very similar kind of thing to what you see on the left. But here, the key thing is that these cloud.services are actually going to be deployed into my target environment, which in this case is AWS. And so these will actually stand up all the resources they need in AWS. They'll stand up some Fargate tasks using the serverless container offering from AWS. They'll stand up a load balancer in front of this port so that you have access to it. If you want to specify that there's some number of replicas, they'll stand up that many replicas of the underlying service. And then for this example that does a build, whereas in Docker Compose I can only use build when I'm working locally, in Pulumi I can actually use build even when I'm working with something that's deployed into AWS. And they can do that because we'll actually run the Docker build locally on the machine, and then we'll push that up into a private repository that we've allocated for this service in AWS. And so all of that is just managed automatically as part of this cloud.service, but it gives you, again, the very high level and simple way of kind of describing these things. The one other thing is that because we have kind of the full capabilities of the sort of a language and the ability to sort of integrate things using code, we can also take advantage of things like if I want to publish out the endpoint that this is available at, so the HTTP URL where this website will be available, I can say web URL, and I can say something like web.default endpoint. And this default endpoint actually has a bunch of details on it. So what I want to do is go and produce a string that has the exact format I want. And this is where it's useful to be able to use the full capabilities of JavaScript. So I can compose together http:// I can say the host name of the endpoint. I can do colon, and I can do the port of the endpoint. And so there we go. Now I can actually publish out to people who deploy this application that the web URL that I can access this at is running on this host name at this port and on this HTTP schema. And so that's kind of the handy thing we can do because we have a language, but we could also do anything else we want to pass outputs from this Redis image in as environment variables on the web container. A lot of different things we can do because we're managing this as infrastructure, but using the high-level features of this cloud platform. Okay, so that's sort of an example of Docker Compose. Let me show one last example here. Well, actually, let me just show it in the our examples repo. And this is one that I've kind of talked about several times in the past, probably, if you've watched these. And this is this thumbnailer. And so this is an example that uses kind of the serverless framework. It was based on a blog post that talks about how to sort of build a serverless application using serverless framework and Fargate. And so this example, we have a video that can be uploaded into a bucket that can fire off a Lambda function. And that will itself run a long-running Fargate task, which when it completes, will write a JPEG into a bucket with a keyframe, and then fire off another Lambda event. And so this is this kind of example where we have a very high-level description of our system. We want to sort of turn that high-level description into code. And I'll show kind of very briefly kind of what that looks like in the serverless framework example. And we can see there's several things in here. Set up some environment variables and IAM roles. But you can see, for example, the interesting part of this is sort of these two functions, right? And so we have this sort of very high-level declarative kind of notion of I've got two functions, trigger on upload video and trigger on thumbnail creation, those two different lambdas we saw in that diagram. And they kind of have this very specific format here for how I can hook up the events and say this is S3 and hook it up to a particular bucket. But of course I have to sort of allocate that bucket out of band. That's not created as part of this application. And then I have to sort of manage a bunch of these inputs and configuration manually through the system. One of the things we can do with Pulumi is we can sort of turn that all into code and get some of the same high-level benefits of thinking about things just as event handlers and not having to deal with all the raw underlying resources. But with the flexibility to also integrate in all the other pieces of the application, like managing the raw infrastructure, creating that bucket inside the program itself, managing the Fargate task inside the same program. And so here we've created a task to go and run this Dockerized thumbnail extraction. But then ultimately to do the same sorts of things where I say bucket.onPut, and then key suffix JPEG. So the similar kind of thing to hook that up in a very high-level way, with the added benefit that now I can describe the contents of those functions actually in line here, because in this case, and in many cases, the contents of those functions is actually very small. So in general, you can see this notion that if you have some existing kind of serverless application and you're looking at one of these sorts of blocks like functions, we have a library called AppPulumi Serverless, which provides pretty much one-to-one things for all the different event sources you might want to use. So if you're using an S3 event source, if you're using a DynamoDB Streams event source, if you're using an API gateway and event source, all of those cases we have this Pulumi AWS Serverless library, which is a kind of one-to-one way to map these into Pulumi as well. So okay, that was a quick tour of kind of some of the paths we've seen kind of folks migrating into Pulumi from various other sort of technologies for managing cloud resources. The couple of key things I'd sort of summarize with: one, it's very easy to migrate into Pulumi just one particular piece of an application, or just dip your toes in. You can always reference existing resources managed by existing other systems, whether it's CloudFormation or Serverless framework or Terraform or anything. And so it's very easy to get started and try out Pulumi inside sort of an existing application. The second thing is, the general benefits of kind of providing a continuum between these is that you can kind of mix and match wherever you want to be at a higher level that's more productive. You can be. Whenever you want to be at a lower level where you have access to all the details of the underlying platform, you can do that as well. And so that combination is really the thing that differentiates Pulumi from many of the different offerings here. And then finally, really treating your infrastructure as software, not just as text, is really valuable. Getting type checking, getting completion lists, getting all these sorts of features. That is just brings the level of robustness of the software engineering practices up to kind of a different level, and that's a key feature that we hope we can bring into many of these other domains as well. So with that, I'll kind of wrap up for today. You can reach out to us at any of these locations, either on Twitter, on our Slack channel, on GitHub, or drop us a note here on the Pulumi TV YouTube channel. You can get started with Pulumi at https://pulumi.io. where you can download the CLI and start deploying applications with Pulumi right away. Thanks a lot for joining us today. If you have any thoughts for topics we should cover in coming weeks, feel free to drop me a note on any of those places I mentioned before. See you again next week. Thanks a lot.